So once again, good morning to all of you. നമ്മൾ നെറ്റ് കോച്ചിങ്ങിന്റെ രണ്ടാമത്തെ ക്ലാസ് ആണ് ഇലക്ട്രോഡൈനാമിക്സിന്റെ. നമ്മൾ ഇന്ന് ഇലക്ട്രോഡൈനാമിക്സിലെ ഗോസ് തിയറും അതിന്റെ ആപ്ലിക്കേഷനും അങ്ങനെ ഒന്ന് ഡിഫറെന്റ് ടൈപ്പിലുള്ള 2-3 പ്രോബ്ലങ്ങൾ ചെയ്യാം. So actually we know that the Gauss theorem, the surface integral E dot ds, that's is equal to 1 by epsilon 0 times total charge enclosed in a Gaussian surface. So here നമുക്ക് എപ്പോഴും ഒരു closed surface consider ചെയ്യും. If Q1 is one charge within surface, Q2 is the another charge within surface, if let Q3 is another charge, it is outside, then the total flux phi, the electric flux phi, this is another expression for phi, where E is the electric field, D is the area, then 1 by epsilon. Here Q1 and Q2 within that Gaussian surface, then we can write it as phi is equal to summation over Q by epsilon 0, that's equal to Q1 plus Q2 by epsilon 0. This is actually the basic of Gauss theorem. So phi is equal to surface integral E ds. Then we depend upon the angle, we can write it as surface integral E ds cos theta. That's is equal to 1 by epsilon 0 times total charge enclosed by any Gaussian surface. So here we are doing one problem. Let's consider two uniformly charged infinite plane sheets. Let's consider this is a plane sheet which is uniformly charged with the plus Q or positive Q. Then we can write it as plus sigma is the charge density. Actually, we know that there are 3 types of charge density we can discuss. Let lambda is the line charge density in a line or current carrying wire. Then total charge Q is equal to lambda into L. If we consider a charge sheet and this charge is uniformly distributed through this surface, then sigma is the charge density and sigma into A, that is the total charge. If we consider any volume, any space or volume space, then if rho is the volume density, then rho into volume is the total charge Q. So here if we know that the charge density, we can write it as Q is equal to charge density into, if it is line, into line integral, total line, the value of total length, total area, total volume. So Q is equal to lambda into L, Q is equal to sigma into A, Q is equal to rho into V. Here let's consider plus sigma is the line charge density of one plane and minus sigma is the line charge density of the another sheet. Two uniformly charged infinite sheet or plates. So we can consider as it is minus charged sheet, it is positively charged sheet with the charge density plus sigma and minus sigma, intercept at 90 degree. So this is in question, it is also given, it is intercepted at 90 degree. Find the electric field at any point and sketch the electric field line. A question 2-part, we have a 2-part question. First part is find out the electric field. Find out the value of electric field. B, draw the electric field. Let us net in the charge sheet and the figure A, B, C, D. And which one is the direction of electric field? We know that the electric field is always flow from the positive charge to negative charge. It is like this. So here also it is positive, it is negative. So let me consider this electric field line, it is going or moving like this. And again it is plus sigma. Here also it is plus sigma. So the field lines, if it is a field lines equal distance, that it is a distance r from center, it's also r from center. So if we consider distance r, it is also moving plus to minus sigma. So here also it is plus to minus sigma. It is also plus to minus sigma. So this is the actually the diagram of field lines. So similarly, we can draw more than one diagram. If it is one is here, then the option, നമുക്ക് different option direction arrow മാറ്റി തരും. So it is clearly it is from positive to negative, positive to negative, positive to negative. If we can draw one more electric field lines, it is positive to negative, positive to negative, positive to negative, again positive to negative. So similarly, we can draw the electric field line. So ഇപ്പൊ നമുക്ക് ഇതിന് പകരം ആരോ തിരിഞ്ഞോ അല്ലെ സ്പെറിക്കൽ ആയിട്ടോ ലൈൻ നേരെ ആയിട്ടോ ഡിഫറെന്റ് ഫിഗർ തരാം. സോ അവർ ഓപ്ഷൻ ഈസ് ആൻസർ ഈസ് ലൈക്ക് ദിസ്. If it is option A, our option is A. The field line starting from positive and ends in negative. That is a concept. Now we want to find out the value at any point. So we know that the value of electric field, actually in if it is a charged sheet, we are considering a cylindrical Coulomb space or Gaussian surface like this, then the electric field is equal to sigma by 2 epsilon. So we want to know that due to plus sigma, the value of electric field due to a positive charged sheet is equal to sigma by 2 epsilon 0. That is the electric field value. And here the electric value is equal to minus sigma by 2 epsilon 0. Then what about the influence? One is plus sigma is like this, minus sigma is like this, one is like this, one is like this. So the net effect at any point P, which both are perpendicular, so the net direction of the electric field is passing like this. Or we can draw a line of if we take it is plus sigma or E1 or E2, then the value of this one is equal to square root of E1 plus E2. Either a triangle to consider either in the base with the square root of base square plus altitude square is equal to hypotenuse square. So that we can find out E1, let consider E1 is the due to plus sigma and E2 is due to minus sigma, which are perpendicularly arranged. Then the total electric field value is equal to square root of this two, E1 square plus E2 square. So that we can solve easily by sigma by 2 epsilon 0 square root of sigma by 2 epsilon 0 whole square plus minus sigma by 2 epsilon 0 whole square. That we know that we can take the root. Then we can here take the negative square of this negative, it is also become positive. That is equal to square root of sigma square by 2 4 epsilon 0 square plus sigma square by 4 epsilon 0 square. That is equal to, we can add it together 2 times. 2 times of sigma square by 4 epsilon 0 square root of, that's equal to square root of 2, that is equal to root 2 sigma by 2 epsilon 0. Root 2 sigma by 2 epsilon 0. So this is our answer. The value of our net electric field, that is equal to root 2 sigma by 2 epsilon 0. Or if another ways, if answer is given is like that, that is equal to root 2 into root 2, that is equal to 2 Then we can cancel one root 2, then sigma by root 2 epsilon. This is the value of the electric field due to this positive and negative plates which are perpendicularly arranged in a space. So this type of different problem by arranging two parallel sheet, then arranging two parallel sheet like this, plus sigma and minus sigma, and also if one is minus sigma, also another is also negative sigma, one is positive sigma, one is negative sigma, like a parallel plate capacitor. So different type of positivity. Just consider the concept. If it is positive, the field line starting from it and going outward. If it is negative, the field lines coming to into that negative sheet or plate. Now we can do the second problem. Find out the potential and electric field along the axis of a circular ring. The circular ring is given. Here its axis. With a uniform charge density lambda. So let lambda is the line charge density of this circular ring. We want to find out the potential at this point. So we didn't given any another idea. So we know that we want to find out the value of electric field capital E, and we want to find out capital V. This is a line charge density lambda is given. So we know that Q is equal to lambda into total length. So here we can consider a very small line element DL. And we can join this point to whatever the point we want to find out. Let's consider small a is the radius. And let's consider this is the axis X or Y or Z. Z is the axis and length is Z. Then the line element, I consider a very small line element DL. Then DL to this point, let's consider this is a point P, that R is the distance from this line element to this point P. Is there any idea? So Q is equal to lambda into total length. Then we can write it as phi is equal to Q by epsilon 0. So here we can write it as d phi, the change in phi is equal to dq by epsilon 0. Or in terms of dl, we can write it as lambda into dl. dq equal to d phi equal to dq is replaced by lambda into dl by epsilon 0. Now, the value of change in flux due to this lambda dl of a circular ring, that means the flux change in electric flux d phi at any point, that is equal to 1 by 4 pi epsilon 0 q by r square. Here r is the distance of this value, so that we can write as 1 by 4 pi epsilon 0 lambda into dl by square root of we can 1 by 4 pi epsilon 0 q by r. So Actually, Q, we want to write R is equal to root of A square plus Z square. So that is equal to D phi. I think it maybe make some confusion. I say some more thing about this problem. Let you consider our value of f. We know that f is equal to 1 by 4 pi epsilon 0 q by r square and f equal to q into e. Therefore, e is equal to 1 by 4 pi epsilon 0 q, sorry, 1 by 4 pi epsilon 0 q1 q2 by r square. We can divide by 1 q by r square. And electrostatic potential V is equal to 1 by 4 pi epsilon 0 q by r. Or you just take this equation, then it is become very easy. Then V is equal to, then 1 by 4 E is equal to 1 by 4 pi epsilon 0 q by r. dV is equal to 1 by 4 pi epsilon 0 dq by r, or dV is equal to 1 by 4 pi epsilon 0 lambda dl by r is equal to root of a square plus z square. I think it is very simple. We can directly solve this problem by using calculating E and V from V, because we know that E is equal to minus del, if in terms of del phi or del V, E equal to minus del V. So we can find out E and V. So we can find out dV is equal to 1 by 4 pi epsilon 0 lambda dl by root of z square plus a square. Then we can take the integral of this value, then we obtain V. Then V is equal to lambda by 4 pi epsilon 0 into 1 by root of a square plus z square into integral dl. dl is this small value, so the total integral of this line, that means this much of this radius of this area covered by, sorry, the circumference of this one, that is equal to this value 2 pi r. So we can write it as integral of dl is equal to 2 pi into radius. Here we can write it as 2 pi into a. So that is equal to lambda by 4 pi epsilon 0 1 by root of a square plus z square into 2 pi a. So that is equal to, now we can take it as the final value 1 by 4 pi epsilon 0 by 4 pi epsilon 0 into 2 pi lambda a by root of a square plus z square. Actually, this is the value of V. One part is over. Now we want to calculate E. So we know that E is equal to minus del V, or that is equal, if it is, we can take it is in Z direction. So this is del is equal to I into dou by dou Z. So that is equal to dou by dou Z minus dou by dou Z of this V. 1 by 4 pi epsilon 0 into 2 pi lambda a by root of a square plus z square. So we can take the differential of only this value. We can take all other values constant, minus 1 by 4 pi epsilon 0 2 pi lambda a into 1 by root of a square plus z square. Now we want to take the derivative dou by dou z of this value. So actually this root of a square plus z square is in denominator, so we can write it as a square plus z square all raised to minus 2. Hence differential become minus n into a square plus z raised square into n minus 1 minus 2 minus 1. Here it's simply, if it is in root, we can take it as minus 1 by 2. So minus 1 by 2 into minus 1 by 2 minus 1. Here I will write here. That is equal to a square plus z square. Is in numerator, we can take it as, it is in denominator, we going into numerator, it become negative. It is in root, within root though, so it here it is 1 by 2. So take in numerator, it become minus 1 by 2. So n into minus 1 by 2 into a square plus z square raised to n minus 1 minus 1 by 2 minus 1. So for subtract, we can take the reciprocal, plus into minus is equal to multiply here 2 into 1 minus 2 plus 1 minus 3 minus 1 by 2 into a square plus z square all raised to minus 3 by 2. So it is minus 3 by 2. You can write it in the denominator as a square plus z square raised to 3 by 2. Then our equation become minus 1 by 4 pi epsilon 0 2 pi lambda a into minus 1 by 2 into 1 by a square plus z square all raised to 3 by 2. Can cancel this value, and also there is negative value we can cancel. So the final answer become 1 by 4 pi epsilon 0 2 pi lambda a, denominator 1 pi into a into lambda z by here also, here is n into a raised to n minus 1 into, we want to take the derivative of z also, 2 derivative of z square, that become 2z. So there is a 2z term also in numerator. So here we can write a 2 and we can write an z here. So 2 pi a lambda z by z square plus a square all raised to 3 by 2. If it is in z direction, we can write the unit vector in that direction. So this is the value of v. So it's a very important and a very good problem, because we want to know the concept. We just leave this portion. F is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. A equal to 1 by 4 pi epsilon 0 q by r square. V is equal to work done to bring a charge from one point to another, that is equal to 1 by 4 pi epsilon 0 q by r. Then we take dv in terms of dl. This is a small portion dl. Then take the total L, that is equal to 2 pi r or 2 pi a. Then r is equal to a square plus z square. Now substitute that value in our equation. Then we take the integral of 2 pi, dl, that is equal to 2 pi r. Now just to integrate this value. Sorry, take the differentiation. E is equal to minus del v. E is equal to minus del v. Then we can take the derivative in direction. If we take in the upper direction or x direction, any direction we can take, then the answer is here. In the option they given is that as the unit vector in the final answer. So I taken it as z direction. So minus dou by dou is of this value. Then take the derivative 1 by root of a square plus z square. We take into numerator, it become always minus 1 by 2. Then n into a raised to also n into a raised to n minus 1. Then also take the derivative of this z square, that become 2z Then we can substitute all these things. We can get the final answer V is equal to this value. V is equal to 1 by 4 pi epsilon 0 2 pi a lambda z by z square plus a square all raised to 3 by 2 into the unit vector in that direction. We can solve one more problem in terms of this flux and electric field. Let's consider a hemisphere. Here we can consider a hemisphere. Then the field lines is passing through it. Consider this is electric field lines passing from, that means we know that it is positive, this is negative. So field line passing from positive to negative, and hemisphere of radius capital R. So this radial value of this value is equal to capital R. Then we can take a small line surface integral here, that is ds. Then ds is pointing in that direction with respect to this r. Then we can take theta is that. This much of thing we want to see. A hemisphere of radius r is in constant electric field. Capital E is the electric field directed perpendicular to the base to the upper direction. So we can draw the figure is like this. Determine the flux through the curved surface. We can calculate phi of this curved surface. Again, do we have two equations? Phi is equal to surface integral E dot ds, and phi is equal to Q by epsilon. So we can take this equation phi is equal to surface integral E dot ds. It's another type of problem that is equal to surface integral E ds cos theta. Now it is a sphere. We want to assume some concept here. If it is a sphere, let's consider it is one portion, this is x, this is y. If it is z, one portion is like this. Is a value of the sphere portion in this direction. And when it is come to this 180 degree or 2 pi. So this height, this difference is 90 degree. So in spherical polar coordinates, we can take theta and phi. So theta is equal to maximum 0 to 90 degree here. And this rotation to complete a sphere, it is from phi is in this direction, and phi is from 0 to 180, or phi is from 0 to 2 pi. So here the surface integral ds, we want to differentiate ds in terms of spherical polar coordinates. Then that's equal to surface integral E cos theta into ds, or E cos theta into integral ds. That is equal to, we can write it as E cos theta into double integral of theta from 0 to 2 pi, and or we can write it as or 0 to pi by 2. And what about the value of dr? Dr is equal to, or ds is equal to r square sin theta d phi d theta, or say r square sin theta d theta d phi. Here I write d phi, this r square, if r is the radius, r square into sin theta into 0 to 2 pi. It is angle d phi into d theta from 0 to 2 pi. That's equal to d phi. So this is a phi from 0 to pi. So it is d theta. So we can take the derivative. Derivative of sin theta is equal to cos theta. Then we can take cos theta from 0 to pi by 2. That's equal to E. So this is theta also the variable, so we can take it into the inside. So this is equal to E into integral 0 to 2 pi, integral 0 to pi by 2, sin theta r square into sin theta cos theta d theta d phi. Where cos theta is there, it's also variable with respect to theta. So it is sin theta cos theta. It is product rule. It is very difficult to differentiate. So we can take it as cos 2 theta is equal to 2 sin theta cos theta. So sin theta cos theta is equal to cos 2 theta by 2. And that's equal to E into integral 0 to 2 pi, integral 0 to pi by 2 into r square into cos 2 theta by 2 into d theta d phi. Here there is no differentiation with respect to phi, that we can neglect these two things. Only the variable is in terms of theta. Then we can take the derivative of cos theta is equal to minus sin theta. That is equal to E into r square into minus derivative of sin. Oh, actually here there is that is equal to cos 2 theta is equal to 2 sin theta cos theta. So take the derivative, that's become sin 2 theta. Actually here there is a slight mistake is there. Actually this value, this is sin 2 theta. So sin 2 theta is equal to 2 sin theta cos theta. Then sin theta cos theta is equal to sin 2 theta by 2. Then we can substitute sin theta by 2 here. Then take the derivative, it is become cos. Sorry, we can take the integration. So derivative, integral of sin theta is equal to minus cos theta. Minus cos 2 theta by 2 from 0 to pi by 2. Because in terms of theta, this variation 0 to 90. So that is equal to E into r square into cos 2 theta and means cos 2 into pi by 2. That is equal to cos pi. Cos n by is equal to minus 1 raised to n. It is pi, that is equal to minus 1 raised to 1 into 1. 1 into pi, so minus 1 raised to 1, that's equal to minus 1. That is equal to minus into minus 1, that is equal to plus 1 by 2. That is equal to minus 1 raised to n. So minus cos 0, that is equal to 1. Then here, now we can take there is no term with respect to d phi. So we can take, we done the integration up to this value d theta. Now we can take integral 0 to 2 pi d phi. So 1 into d phi, that is equal to 5. 5 from 0 to 2 pi, that is equal to 2 pi. So the final answer is equal to E pi r square. So that is the value of the electric field. Some doubt is there because of this one. And we want to just know this equation. Sin 2 theta is equal to 2 sin theta cos theta. Then ds is equal to, for spherical polar coordinate, ds is equal to r square into sine theta d theta d phi, and we want to know cos n pi is equal to minus 1 raised to n. If cos pi, that is equal to 1 pi, that is equal to minus 1 raised to n, that is equal to minus 1. Then here integral of 0 to 2 pi d phi, that's equal to phi from 0 to 2 pi, that value equal to 2 pi. We can use this all equations here and substitute all equations. We obtain the final given answer. It's actually given in option B, that is equal to e pi r square. Okay, thank you.